All right, welcome to The Explainer. Today, we are transforming abstract Python code into tangible, practical building blocks. If you've ever felt like your Python code is basically running you rather than you running your code, well, you are in exactly the right place. We're going to take the absolute core concepts of Python, specifically how to control the flow of your logic and how to package that logic into reusable functions, and we're going to break them all down visually. By the end of this, we'll look right past the syntax together and really grasp the underlying architecture of solid Python programming.
Okay, be honest. Think about this for a second. If you had to repeat 50 lines of code every single time a guest knocked on your door, would you actually do it? No way, right? In the real world, when a guest arrives, you don't list out 50 highly specific robotic steps just to make them a cup of tea. That would be completely exhausting. You just say, hey, make tea. Yet as programmers, we kind of do this all the time. We find ourselves writing the exact same lines over and over. So let's fix that. We're going to learn how to teach Python to recognize the simple command make tea, so you literally never have to repeat those 50 lines again.
So, here's the game plan for today. First up, controlling the code flow. Second, functions, your building blocks. Third, parameters, passing the data. Fourth, return, capturing the output. And finally, we'll wrap it all together with the shopping cart project. Let's get into it.
Section 1, controlling the code flow. The illusion of the straight line. You know, when you first learn Python, you're taught that it's an interpreted language. That just means it reads your code like a book, right? Sequentially, straight from top to bottom. Line 1, then line 2, then line 3. Simple enough. But here's the thing. Real-world logic is rarely a straight line. Enter control flow. This is where you essentially become a traffic cop for your code. Instead of forcing Python to mindlessly run every single line, you tell it to completely skip entire blocks of code based on simple true or false conditions. You're fundamentally changing the execution path of the script based entirely on the rules you set. Let's look at a concrete example using the if, elif, and else keywords. We've got two people here, Surzia, who's 23, and Sir Qasim, who's 29. Now our program needs to dynamically figure out who is younger. Since Python doesn't speak English, we use a mathematical comparison. We write an if statement, if Surzia's age is less than Sir Qasim's age. The program takes a look, sees that 23 is indeed less than 29, and boom, it returns true. The code under that specific block runs, and it completely ignores the elif checking if they're equal and skips the else block entirely. Your traffic cop did its job flawlessly. Section 2, functions, your building blocks, the recipe for automation.
Okay, so we know how to make decisions now, but what about all that repetition? Remember our tea analogy? Without functions, your code is basically a rigid, boring list of steps. Add milk and water. Boil the mixture. Serve to guests. Imagine you have 10 guests showing up at completely different times. You're copy-pasting those 3 lines 10 times. It clutters up your script and just makes a massive headache to manage. But if you wrap those steps inside a death block and name it make tea, you've just created your own custom, user-defined function. Problem solved.
And that brings us to this crucial takeaway. Functions are building blocks. Create them once, use them everywhere. It's important to realize that when you define a function, you aren't actually running the code yet. You're just drawing up the blueprint. You're carving out the block. Once it's made, you can drop that exact block anywhere in your code as many times as you want simply by calling its name. It's the ultimate modular approach. Moving right along to Section 3, parameters, passing the data, giving instructions. Having a basic function is great, sure, but what if you need it to actually adapt to different situations? Like, what if you want to say, hello, John, and then, hello, Sarah, without writing 2 entirely separate functions? You have to pass data into it. Think about a wedding. What is absolutely non-negotiably required for a wedding function to work? You need the bride, the groom, the witnesses, and the causey. In programming, we call these required parameters. If you try to execute the wedding function and you, say, forget to pass in the groom, well, the whole thing crashes. Everyone goes home unhappy. Python operates the exact same way. It needs its required parameters. Now let's quickly clear up some terminology because this honestly trips up so many developers. Parameter versus argument. A parameter is just the variable name you defined inside the brackets when you first create the function. Think of it as an empty parking spot. An argument is the actual tangible data value, like the name Surzia or the number 25, that you pass into those brackets when you call the function later. The argument is the car you actually park in the spot. Parameter's the placeholder, argument's the real deal.
Section 4, return, capturing the output, the final state.
Listen, if you take one single thing away from this explainer, make it this: print versus return. Beginners mix this up constantly.
If you just use print inside a function, Python simply flashes the result on your screen, but the program itself immediately forgets it. State is lost. If you try to save that result to a variable, Python literally gives you none. Return, on the other hand, captures the final termination state of the function. It tells Python, hey, stop running this code and hand this exact value back to whatever called me. This is what allows you to actually store the output into a variable so you can do cool stuff with it later.
Section 5. The Shopping Cart Project, bringing it all together.
Let's see how all this builds into a practical, real-world application. We're going to combine control flow, parameters, and return statements to simulate a checkout machine. But first, a tiny problem. When you go shopping, you don't always buy exactly 3 items, right? Sometimes it's 1, sometimes it's 50. A function with exactly 3 required parameters is just too rigid for that. The fix? An unlimited positional argument. By slapping an asterisk right before our parameter name, like *nums, we're telling Python, look, just accept as many arguments as the user throws at you and pack them all nicely into a list for me. So picture a customer walking up to our checkout. They've got 3 items. Item 1 is 3,000, item 2 is 4,300, and item 3 is 5,900. We can dynamically pass these 3 specific arguments into an add all function using that awesome unlimited parameter feature we just talked about. A function runs, adds them up, and crucially, uses the return statement to hand us back the final state. The total comes out to exactly 13,200. And because we used return, not print, but return, we can confidently save that 13,200 into a variable and pass it straight into the next phase of our software.
Which brings us to the magic of nested functions, basically calling one function inside another to create an assembly line. Our main checkout function is running the show. Step 1, it calls the total price function and gets our 13,200. Step 2, it takes that exact total and hands it over to an apply discount function. Inside there, an if statement checks the number. Since 13,200 is safely under 50,000, it generously applies a 30% discount. Step 3, it grabs that new discounted price and passes it to a calculate tax function, which tacks on a standard 17% GSD.
And voila! After successfully routing our data through all those modular building blocks, passing arguments, using control flow, and capturing the return values, our final net total pops out 10,810. We took raw, messy data, manipulated it through multiple custom functions, and got a precise, automated result. It's beautiful. We have covered a ton of ground today, from shattering the illusion of the straight line to building a fully dynamic nested shopping cart. You now know exactly how to dictate flow and construct powerful, reusable blocks of code. So I'll leave you with this final question. Now that you actually have these Python building blocks at your disposal, what repetitive, mind-numbing task in your own life are you going to automate first? Thank you so much for watching, and keep coding.